In the world of technology, some companies grow, others innovate, but a select few achieve something far more profound. They don't just participate in a revolution, they become the engine that drives it. NVIDIA didn't just grow, it took over. Today, its name is synonymous with the artificial intelligence explosion, a silent partner behind nearly every major breakthrough. But this wasn't an overnight success. It was a story of vision, risk, and a decades-long bet on a future that few could see. The story begins not in a sterile boardroom, but in a humble Denny's diner in San Jose, California. It was 1993. Three engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, met to discuss a bold idea. They saw that video games were pushing the boundaries of personal computing, demanding a new kind of processor dedicated solely to rendering complex, three-dimensional graphics. They believed that this niche, graphics processing, would one day become a massive market. With $40,000 in the bank, they founded NVIDIA. Their initial focus was singular and relentless: build the best graphics cards for the burgeoning world of PC gaming. The early days were fraught with challenges. The market was crowded with competitors, and their first chip, the NV1, was a commercial failure. It was a harsh lesson in market dynamics, but one that forged the company's resilience. They learned they couldn't just build interesting technology. They had to build what the market and the developers truly needed. Their comeback was the Revo 128 in 1997, a chip that established their reputation for performance. But it was the GeForce 256, released in 1999, that changed everything. NVIDIA marketed it as the world's first GPU, or Graphics Processing Unit, a term they coined to differentiate it from the less capable graphics cards of the era. This wasn't just marketing, it was a statement of intent. The GeForce line of GPUs quickly became the gold standard for gamers. Each new generation brought staggering leaps in performance, enabling unprecedented levels of realism and immersion in virtual worlds. They were fast, powerful, and consistently ahead of everyone else. NVIDIA cultivated a deep relationship with the gaming community, understanding that these passionate users would always demand the absolute cutting edge. They built a powerful brand, not just on hardware, but on the experiences that hardware unlocked. For millions, the phrase NVIDIA, the way it's meant to be played, wasn't just a slogan, it was a promise of quality and performance. While gamers pushed their GPUs to the limit rendering fantasy worlds, a different kind of revolution was brewing in labs and universities. The key was realizing that a GPU's architecture was unique. While a CPU, the brain of a computer, is designed with a few powerful cores to handle tasks sequentially, a GPU has thousands of smaller, simpler cores. It's designed for parallelism, the ability to perform thousands of simple calculations simultaneously. This is perfect for rendering millions of pixels on a screen, but a few visionaries saw another application. In 2006, NVIDIA made a pivotal decision that would alter its destiny forever. They released CUDA, a parallel computing platform and programming model. For the first time, CUDA gave developers and scientists direct access to the immense parallel processing power of the GPU, allowing them to use it for general-purpose computing. It was a gamble. They invested heavily in creating a software ecosystem, compilers, libraries, and tools to make GPU programming accessible. They weren't just selling chips anymore, they were building a platform. Then, in 2012, the spark met the kindling. Researchers discovered something huge. A team from the University of Toronto, led by Geoffrey Hinton, used two NVIDIA gaming GPUs to train a deep neural network called AlexNet. They entered it into the prestigious ImageNet competition, a benchmark for computer vision. The results were staggering. AlexNet obliterated the competition, achieving an error rate so low it was previously thought impossible. This was the big bang moment for modern AI. The secret was that training a deep learning model involves a mind-boggling amount of matrix multiplication, a type of math that GPUs, with their thousands of parallel cores, were uniquely suited for. NVIDIA's GPUs were perfect for artificial intelligence. The CUDA platform they had been building for years was suddenly the essential tool for this new frontier. The academic world took notice, and the race was on. NVIDIA seized the moment, pivoting its strategy to dominate this new market. They understood that training AI models requires massive, almost unimaginable computing power, and NVIDIA already had the best hardware. They began designing chips specifically for AI and high-performance computing. This led to the creation of their data center-grade GPUs, like the A100 and the even more powerful H100. These weren't just souped-up gaming cards, they were purpose-built AI engines, featuring specialized tensor cores designed to accelerate the exact mathematical operations used in deep learning. But the hardware was only half the equation. They also engineered an entire infrastructure around it. Technologies like NVIDIA Link allowed multiple GPUs to be connected with ultra-high-speed interconnects, effectively making a rack of servers function as one colossal GPU. They built the hardware, the software, and the networking fabric, creating an end-to-end platform for building and deploying AI at scale. With this powerful, integrated platform, NVIDIA became the indispensable foundation of the AI industry. Today, the vast majority of AI systems, from the large language models like ChatGPT that generate human-like text, to the computer vision systems that guide self-driving cars, run on NVIDIA GPUs. The company expanded beyond chips, offering vertical solutions for specific industries. NVIDIA Drive provides the hardware and software stack for autonomous vehicles. In healthcare, their Clara platform accelerates medical imaging and drug discovery. And with Omniverse, they are building a platform for creating and simulating virtual worlds, or digital twins, for industrial and creative applications. They successfully transformed from a hardware company into a full-stack computing platform company, with their technology embedded in nearly every facet of the modern AI ecosystem, from cloud data centers to edge devices. This dominance has not gone unnoticed. NVIDIA's position is so central that it has created a unique market dynamic. Major cloud providers and tech giants, while being NVIDIA's biggest customers, are also developing their own custom AI chips to reduce their dependency. Competitors like AMD and Intel are racing to create viable alternatives, hoping to capture a piece of the exponentially growing market. But NVIDIA's advantage isn't just its hardware. It's the decade-plus head start in building the CUDA software ecosystem. Millions of developers are trained on it, and a vast library of AI models and applications are optimized for it. This creates a powerful moat, a defensive barrier that is incredibly difficult and expensive for rivals to cross. However, this near monopoly also brings risks. The world's AI progress is heavily reliant on a single company's supply chain. Geopolitical tensions, manufacturing bottlenecks, and the immense energy consumption of AI data centers are all significant challenges that NVIDIA and the entire industry must navigate. The financial impact of this strategic positioning has been nothing short of astronomical. As the demand for AI compute exploded, so did NVIDIA's revenue and stock price. The company's valuation soared, placing it in the elite club of the most valuable companies in the world, alongside tech titans that have been household names for decades. This meteoric rise was fueled by an insatiable demand for its data center products. Each new generation of AI models requires more computational power, driving a relentless upgrade cycle. NVIDIA became one of the most valuable companies in the world, all because of a bet on AI that it placed long before anyone else. The company's journey from a Denny's diner to the pinnacle of the tech world is a masterclass in long-term vision and execution. At the heart of this journey is CEO Jensen Huang. He saw the future early and bet everything on AI. His conviction that accelerated computing would redefine every industry has been the company's guiding principle. As AI continues to evolve from a research tool into a general-purpose technology, NVIDIA's role only becomes more critical. As AI grows, NVIDIA grows with it. The next wave of AI, including autonomous agents and advanced robotics, will demand even more powerful and efficient computation, from massive cloud servers to tiny devices at the edge. The story of NVIDIA is far from over. In many ways, this is just the beginning. To continue exploring the companies and technologies shaping our future, subscribe for more AI stories and tech breakthroughs.